Imagine a world where a simple scratch from a rose thorn or a sore throat could be a death sentence. Before 1928, doctors were almost helpless against bacterial infections. During World War I, more soldiers died from infected wounds than from actual wounds inflicted in battle. Scientists were searching for a magic medicine, a substance that could kill bacteria without harming human cells. Little did they know, the answer would come from a messy lab and a forgotten vacation. In 1928, Scottish bacteriologist Alexander Fleming at St. Mary's Hospital in London left for a 2-week holiday. Being famously untidy, he left a stack of Petri dishes containing Staphylococcus bacteria on his bench instead of in an incubator. When he returned, he noticed something strange. A common mold, Penicillium notatum, had contaminated one of the dishes. But around the mold, there was a zone of inhibition, where no bacteria grew. He realized the mold was secreting a juice that dissolved the bacteria. He named it penicillin, but Fleming found it difficult to isolate this precious mold juice in large quantities. After 1940, Howard Florey and Ernst Chain became interested in penicillin. In time, they were able to mass-produce it for use during World War II, and it saved a lot of lives. Penicillin is a bactericidal antibiotic, meaning it works by directly killing bacteria rather than just slowing their growth. Penicillin targets a specific molecule called peptidoglycan, which forms a mesh-like lattice that gives the bacterial cell wall its strength. Penicillin contains a chemical structure called a beta-lactam ring. This ring mimics the natural building blocks that bacteria use to link peptidoglycan strands together. Because of this mimicry, penicillin binds to enzymes known as penicillin-binding proteins, PBPs, specifically transpeptidases. These enzymes are the builders responsible for cross-linking the peptidoglycan layers. Once penicillin binds to these enzymes, it permanently inactivates them. The bacteria can no longer create the cross-links needed to maintain a strong cell wall. Because of this, the pressure changes inside the bacterium, water rushes in, causing the cell to swell and eventually burst, a process called lysis. Why it doesn't harm human cells. Human cells do not have cell walls or peptidoglycan. Instead, our cells are enclosed by a flexible cell membrane. Because the specific enzymes penicillin targets simply don't exist in the human body, the drug is selectively toxic, meaning it kills bacteria without damaging your own cells. The ultimate lifesaver that works by breaking the walls. Isn't it great? And today the mortality rate of pneumonia is less than 10%. Also, people won't die from small infection, thanks to penicillin.